Hello guys. So welcome to the linear law lesson, and in this video I'll talk about the linear law, or why it's done, how it's done, and so on. But before we go into details, you would have understood by the word linear here, which means related to the straight line, right? And the equation of any straight line, you guys are already aware that you can write it in the form of y equals to mx plus c, where m is the gradient, and the gradient of any straight line can be found by this formula that you have learned: y2 minus y1 over x2 minus x1, and c is the y-intercept. That's the point wherever the line intersects the y-axis. So this is being the y-axis and this is the x-axis. So we'll be using this equation, the equation of a straight line, in linear law. So before we go into details, let's see an example. Now here you see a quadratic equation. You all already know that's a quadratic equation. And if you draw a graph of any quadratic equation, it will be, kind of U-shape, opening up or opening down. And in this case, this will look like this: y equals to 2x squared plus 3. But what if we only concentrate on some values on the the right side of the y-axis? So that's in here, y equals to 2x squared plus 3, and we have some values of x. You can see x equals to 1 to 1.5 and up to 3.5, and the corresponding values of y. So when x is 1, y value is 2 times 1 square plus 3, and that becomes 2 plus 3 as 5. That's 5, and so on. You can check for all other values. And then if we plot these x values and the corresponding y values on a graph paper, the graph will look like something like this. Okay, this is the same graph, part of the same graph that we had seen here. Okay, so from here till 3.5 something here, but with a different scale on the y-axis. Okay, so let's go again to that part, and this is how that part look like. But you can see it's this part is still curvy part. Yeah, it's still not a straight line. So about the linear law, any kind of graph, something like this, y equals to x squared plus, which is of course not a straight line, those kind of graphs can actually be obtained in the straight line forms, and hence the name, the linear law. So how do we do that? For that, we have to manipulate, we have to play with these x's and y's. So let's see how to do that with this graph. And for that, let's go to this page again, and here what we will do before we do this, I will just like to tell you that this graph is called as y against x. So the y-axis is on the vertical axis, it's y; on the horizontal axis, it's x. So the graph is said to be y against x. Now in the next one, what we will do is we will try to draw a graph of y against uh, x square. Okay, so in this case, let's get the x square values. So we already had x, these values when we draw the previous graph. Now we will find the corresponding x square values. So 1.5 squared will become 2.25, 2 square is 4, 3 square is 9, and so on. And the corresponding y values are in here. And then we plot those points on y against x square. Okay, so let's see, our first value here is 1 and 5. So you see 1 is here and 5 is here, so that's 1 comma 5. Okay, and so on. 411, so this is 411. Then we have 3.5 and sorry, 12 12.25, which is somewhere here, and then you have the corresponding y value as 27.5. So when you plot y against x squared, you can see it has given you a straight line. Now in this case, in this straight line, if you try to find the gradient, which is, let me choose maybe this point here, 4, and this one here. So if I choose this point here, this is 9, 21 and 4, 11. Right, so you can see the vertical change is 5 and horizontal change is 10. So your gradient will be 10 over 5. It's going on upside from left to right, so the gradient will be positive, and the gradient is 2 actually. Or you can just use y2 minus y1 over x2 minus x1. So now if we try to find the equation of this line, we will write it in the form of capital Y equals to m capital X and plus C. Now, why capital Y and capital X? Because originally the equation is this one, y equals to 2x squared plus 3. So we will replace the y with, whatever these y's and x's must be in terms of x and or y. Okay, it can be in terms of x's or y's, so that depends. We'll talk about that again. So for now, I will write the equation of this straight line here as capital Y equals to m times x plus c. So capital Y is gradient is 2, and then x and plus c. So actually you can actually calculate here value of c, but then here we already know here from the graph, which is 3. So I will directly write 3 here. Okay, now that's the equation of the straight line here. But from this straight line, how do we get the equation of the original line, which is given, the equation of the original line, original graph. So in this case, we have to remember that, okay, let me raise this here. So you remember we had drawn the graph of y against x square. It means your capital Y is this, and your capital X is this one, x square. So we just replace the capital Y with small y in this case, and capital X with the x square plus 3, and that's the equation of the original graph. Okay, so the point here is you can use straight line graph y equals to mx plus c, and then from that you can find the equation of the original graph, and it can be done vice versa. So now why do we do this? Why do we have to use the linear law? Basically in science, when some experiments are going on and you have like two quantities to compare, let's say two kind of data, let's say x and y. So you get some data and you want to find the relationship between those two kind of data, let's say x and y again. So if the best way to know the relation is when you plot the graph, when you plot those data on a graph paper, and if they are already on a straight line form, then there's no problem. You can easily predict the next part. But if they are not forming the straight line, so what usually scientists do is they kind of predict some kind of relation. So they might predict, okay, this looks like this might go something like quadratic or cubic. So they assume that particular formula, and just to know whether it's right or not, they will convert that into straight line form and then cross check with some other values. If it satisfies that equation, that means their prediction about the equation was correct. If it doesn't satisfy on the straight line, that means their prediction about the equation of the graph is not correct. And this really helps them in coming out to a correct relationship between the two different kinds of data. So that's why the linear law is used. And in here, just remember that we have capital Y equals to capital MX plus C as the linear law, where Y can be in terms of X and or Y. Okay, it can be X and or Y, and the X can be mostly just in terms of X's. So it can be like X squared, it can be 1 over X. This here can be xy, it can be 1 x over y, and so on. They can be different. That depends on the main equation given to you. So let's see some examples here. Here are 4 examples, and all of these are of course straight lines. And it's asking you to find y in terms of x. If you look at these, this is just y against x squared. This is 1 over y over 1 against 1 over x, y over x against just x. And then here it is xy against x cube. Yeah, it's cube, x cube. So let me show you the working for part B, and then I would expect you guys to answer the A, C, and D. So let's see this one here. If you want, you may pause the video for now and try to answer yourself. Otherwise, you can just understand this working first and try the other question. All right, you can see this question here. It's xy against x cube. So xy against x cube. Okay, so finding the equation of the line will be y equals to mx plus c. Remember that y in this case is xy, small xy. Capital Y in this case is small xy, and capital X is x cube. So first of all, the important thing is let's find the gradient, which is 5 minus 2 over negative 4 minus 1. And that becomes 3 over negative 4 plus 1. So that's negative 3 over 3. I'm putting minus in the numerator, and the answer is minus 1. Okay, that's our gradient. And now equation will be y equals to negative 1 x plus c. Let's find the value of c. So I'm using the coordinate as minus 1 comma 2, this coordinate here, and that will give me 2 equals to 1 plus c, and c is equal to 1. So now the equation, the linear law equation here is capital Y equals to, the gradient was negative 1, and then capital X and plus 1. So that's our linear law here, minus x plus 1. Now let's substitute the value for capital Y, which is xy in this case. So xy equals to x cube, which is negative x cube plus 1. Since the question says express y in terms of x, so let's make y subject and divide other side by negative x cube plus 1 actually here over x. So let me write this one. That's 1. Okay, now we can say that y equals to, separate the denominator on the right hand side, and that will become negative x squared plus 1 over x. Now that's the actual equation for the given linear, the straight line here. So when you draw the graph of this function here, this equation here, nowhere on this planet will it be a straight line. So yeah, that's about the linear law. I would expect you guys to answer these remaining now, and in the next video or in the next lesson we will talk about more different kinds of equation that's related to linear law. For example, one of the, I can say the famous one can be in this form. So you guys think about this, how to convert this equation here, exponential equation here, into the linear form, that is in the form of y equals to mx plus c. And we'll talk about it in the next lesson. All right, okay, thank you guys. I hope you understand. Let me know later if you have any questions.